In this video, we're going to take an overview look at extending classes in Java. In the next video, we are going to take a hands-on look at it, but in this, we're just going to describe it and show a class diagram as well. First of all, why do we need to extend classes? Well, real-life objects might respond to scenarios in different ways. So far, we've been working through a vehicles program, and we assume that anytime we press the accelerator on a car and the car is running, that we're consuming gasoline. But you might think, well, that doesn't apply to everything. It doesn't apply to a Chevy Volt or a Toyota Prius. A Prius may or may not use gasoline, or a Tesla, if you think of that. A Tesla doesn't use any gasoline at all. So do we have to duplicate all of this logic, or do we have to put in an if test and handle Tesla separately from, say, a Dodge Neon or a Chevy Cavalier? Well, we could use a series of if tests, but that would get very cluttered, and there's a better way to handle this in object-oriented programming, and that's a concept called extension and also a related concept called inheritance. So in this video, I want to talk about those two concepts. First of all, some vernacular. Let's actually start with the second bullet point. A superclass or a parent class is an abstract concept that can be extended upon. So in other words, think about a vehicle without thinking about a specific type of vehicle. That is essentially a superclass. Now, a subclass is an implementation of that abstract concept. So think of a Dodge Neon or a Chevy Volt or a Tesla or a Toyota Prius. Those are all specific types of vehicles, and so that's what we're going to call a subclass or a child class. And that indicates a relation between that subclass and its superclass. Now, the subclass can do some things that are specific to that subclass. For example, the way the Prius decides whether to use the internal combustion engine or the electric motor, the Prius class alone can decide how to do that. But there are some things that it can inherit from the more abstract concept. Things like a model year and a make, like Toyota being the make. These are concepts that can describe any type of vehicle, regardless of its engine. So those are things we are going to inherit from the superclass. Now, it's often that a subclass will override behavior that would otherwise be inherited from the superclass. So in other words, a Toyota Tacoma, a Chevy Cavalier, any of those vehicles, a Toyota Camry, a Honda Accord, most of those are going to function with an internal combustion engine. The Prius may or may not. So the Prius has an option to override default behavior and provide its own specific default behavior. That's what overriding is. Now, attribute, variable type, object type, these are things we've talked about a little bit before. An attribute is a variable declared within a class but not within a method, and this is describing the state of an object. So a state is the value of its attributes. So in other words, a 2008 Toyota Tacoma, which is red, has the attributes 2008, which is the model year, and color, which is red. Those are attributes. Variable type, we know for a variable we need a variable type and a variable name. And then object type is what we store into that variable. So far we've seen the variable and the object type have been the same. In other words, if the variable type is vehicle, the object type is also vehicle. But what we're going to see going forwards is that the variable type and the object type might be different, and this opens up a lot of opportunity for us. So in other words, a variable type might be vehicle, and object type might be Prius. If that's the case, the variable type tells us what methods we are allowed to call, and the object type tells us what will happen when we call those methods. That's a concept called polymorphism. In other words, a variable type vehicle says we do have a method called go, and that method called go accepts a parameter called distance. The object type of Prius says, okay, when I have to go 100 miles, I, as a Prius, am going to decide whether to use gasoline or whether to use the battery charge. So that's a bit of vernacular that we're going to take a look at. Next, let's extend the class diagram that we drew previously and add some of these concepts. So I'm going to go to Argo UML, and you see we have driver and vehicle. One thing I'm going to note, in some videos I refer to this as car, some as vehicle. I use those words interchangeably. I prefer vehicle a little bit because car can be confused with character, C-H-A-R. But nonetheless, vehicle, car, think of those as two in the same. So we know that the driver is the thing. I need to do a little tidy up here. Get rid of this guy. We know the driver is the thing that's going to have all of our input and output. And vehicle is a noun class which is representing a vehicle. So driver is interacting with the user, or vehicle is a noun that the user is interacting with. Now, if I click on vehicle, take a look, and you'll see that I have this kind of yellow arrowhead at the bottom. I'm going to click on that, and I'm going to drag something in here, and we're going to call this a neon. Now, I choose neon because it's essentially one of the most basic car concepts you can think of. I guess you don't see them much around anymore, but this was the car that I had when I was in college. I worked all summer long and saved up my money until at the end of the summer I bought this a neon just like this that was 1 year old, and it's basically what I could afford after working on a summer. But there were very few options. It was a no-frills car. My car did not have air conditioning. I didn't even have the side view passenger mirror that comes over here. Did not have power steering. So a lot of the things that you just think are standard in a vehicle, this vehicle didn't have. Didn't even have a radio. Now, luckily in college I worked at Radio Shack, and so it did have a pretty awesome sound system when I was done with it, but that's beside the point. So a very basic vehicle. Now, around that time there was also the Chevy Cavalier, which was similar but had a few more options. So same kind of size. But it did have a Z24 edition, which was a little bit nicer, and you could occasionally even find it in a convertible, which you could not find the Dodge Neon in a convertible. So you see, the Cavalier is like a Neon, but it has additional features that the Neon doesn't have. Then, of course, we have the Toyota Prius, which is a hybrid vehicle, so it can run on internal combustion or on gasoline, has quite a few more features. So one way we could represent this in theory is go into our driver program and make this vehicle very complex with a whole bunch of if tests, but that quickly becomes unmanageable. So let's go back to our UML diagram and finish this out a bit and think about what the different vehicles are going to look like. So we have our Neon. Neon is going to inherit everything because it is essentially a generic vehicle. After that, I'm going to make a Cavalier. So I click on this button one more time, and you notice we can have multiple classes that subclass one superclass. So in this case, vehicle is our superclass, Neon is a subclass, and then Cavalier is another subclass. For Cavalier, I'll choose New Attribute, and the new attribute I'm going to call Convertible. Okay, and the data type for that, we're going to choose Boolean. Let me just scooch this up a little bit and see if we can choose Boolean. There we go, there's Boolean. So it either is a convertible or it is not. But you notice that's something that's specific to Cavalier, which we are not going to see in Neon or even Prius. Prius does not have a convertible option. So I'll tell you what, let's make that lowercase c convertible as well before I forget. Okay, now we have the Prius, and the Prius has its own state as well. So Prius, and under Prius we'll add a few attributes. We'll say miles per milliamp hour. So in other words, what is the battery storage life in the Prius? How far could it go? So let me try to get these both on one screen. There we go. And this one we'll call MPMAH. Kind of a long acronym, but miles per milliamp hour. And then, or in other words, sorry, miles per milliamp hours. How many milliamp hours do we consume when we drive a mile? Of course, it's not always going to be a standard rate, as it depends on how quickly we accelerate, but we're just trying to model here a little bit. Let me add one more. This new attribute here is going to be an attribute called battery charge. And that one will also make an integer. So at this point, we have drawn out what this inheritance is going to look like. We see that miles per gallon, odometer, and gallons of gas are going to be inherited by each of these different subclasses, Neon, Cavalier, and Prius. But Cavalier has an additional attribute, and so does Prius. Now, Neon and Cavalier, because they're solely internal combustion, will override the go method from they will inherit the go method from vehicle. They're just going to reuse that, no changes needed. But we know the Prius has a bit more intelligence because it needs to decide how it's going to go, via gasoline or via electricity. So for that, we need to override the go method in Prius, and we'll say go distance :integer. So do you see that this has the exact same syntax that we have up here, which indicates an overriding relationship? In our next series of videos, we'll walk through actually doing this in code, and setting up this relationship from subclass to superclass is something we do with a new keyword called extends. I'll point you to a few items you can find on my UC website. These are a bit dated. They go back several years ago when I originally thought this concept for a different class, but nonetheless, inheritance is inheritance and it's still very valid. So 32 IT 206, Computer Programming 2, click on the inheritance trail here, and you'll see a definition of child class and parent class, superclass and subclass, several other things. Some more lightweight class diagrams that show how a vehicle could be a car, could be a truck, an ATV, a motorcycle, anything like this. Back in a few examples that we see in code. And also, at the very bottom, there's an in-class exercise. Now, this is not for a grade, but if you want a little bit of practice with this to try on your own, I have some written out examples as well as the answer key down below, so if you want to practice a little bit. So that's a look at inheritance in Java. Hope this video has been helpful. Thank you.